Here's the solution to Day 1, Problem 1. In question A, rewrite the number into standard form. And we are given a number that is in scientific notation. It has this times 10 piece with an exponent, and that is scientific notation. I notice the exponent's a negative number here. So let's do part A. I'm going to start by writing down that number. And then we're going to think about the meaning of multiplying a number like this decimal by 10 to the negative fourth power. To think about this, let's first consider what 10 to the negative 1 power means. 10 to the negative 1 power, by definition of what a negative exponent is intended to mean in math, is the fraction 1 over 10 to the first power, or just 1 over 10, 1/10. And so this gives meaning to negative exponents in math. A negative exponent's meaning is to create fractional pieces or reciprocals. 10 to the negative 1 power is equivalent to the fraction 1/10, 1/10 of something. Okay. So let's think about what 10 to the negative 4 power would mean. That would mean we have 10 to the negative 1 times another 10 to the negative 1 times another 10 to the negative 1 times another 10 to the negative 1. We have 4 10 to the negative 1 powers being repeatedly multiplied together. That's what 10 to the negative fourth power indicates. Remember that each of these pieces means 1/10. So 10 to the negative 1 power is the same as 1/10. And 10 to the negative 1 power, 1/10. 10 to the negative 1 power is 1/10. And 10 to the negative 1 power is 1/10. So what's going on here when we have a number like 2.158 and we multiply by times 10 to the negative 4 power, that's the same thing as multiplying this number by 1/10, and then again by 1/10, and then again by 1/10, and again by 1/10. Every time you multiply a number by 1/10, that has the effect of making the number smaller, only 1/10 as big as the original. And a quick way to do that with numbers that have decimal points is to move the decimal point one position to the left every time you want to multiply by 1/10. Okay? So timesing by 10 to the negative 4 will have the effect of moving this decimal point not just one spot to the left, but 4 spots to the left. Let's do that. 1 spot, 2 spots. This will need to be filled in with a placeholder 0. 3 spots, and 4 spots. The decimal point's going to be out here at the beginning, and there will need to be some zeros filled in as placeholders in front of these digits. That's going to create the number 0.000258. And so this very small decimal number, this is less than 1 full unit, this is a very small decimal, is equivalent to this number in scientific notation. Now part B. Here we have this number to begin with, 0.000831. This is a standard number, and what we're asked to do is to write this in scientific notation. Now again, the key to writing a number in scientific notation is to always have the decimal point so that there's one non-zero number to the left of the decimal point. Right now, here's the decimal point. There is not a non-zero number to the left. If anything, there's a 0 to the left of the decimal point. We need to have one non-zero number to the left of the decimal point. That means we would like it to go here, so that the digit 8 is that one number that comes to the left of that decimal point. So that means we need to move the dot. Let's count. 1, 2, 3, 4 spots. That's going to create 3, 1. And now times 10. Remember how it was 4 spots? But let's put some careful thought into this. If we write an exponent of 4, meaning a positive 4, and we think about what 10 to the 4th power does, that would move this dot 4 spots to the right, creating a larger number. Our original number was this very small decimal. So it's not a positive 4 that we need for an exponent. It's a negative 4. And so this number here is the scientific notation version of this number here. Now, day 1, problem 2. Question A, solve this equation. And then question B, check our answer. So question A, let's copy that equation down. 2 times, and now the quantity, x minus 3, is equal to negative 15. I'm going to draw a vertical line downward from the equal symbol. And then we want to solve this for the variable x. We'd like to isolate the variable x. Here is the only x that's in this equation, and it has some other numbers on the same side of the equation as the x. Next to it, there's a subtract 3. Right here, there is a 2, which is being multiplied to the quantity that has x in it. We need to remove the 2 and remove the 3, and then we'll have the x alone. So let's do that. We can, first of all, multiply the 2 to both terms in these parentheses. This is called the distributive property. So 2 times x, we can write down what that is, 2x. And then 2 times the 3, which is 6. And there's a subtraction symbol used to separate these two terms, and so let's continue to use the subtraction symbol right there. And so what's going on here is that we're saying that 2 times the quantity x minus 3, which is like having 2 x minus 3's, could be written as 2x and then minus 6. And that's equal to negative 15. Now that we're done with the distributive property, you'll notice the parentheses are gone, and so we have a simpler looking equation than we did to begin with. Here's the x term. Next to the x term, there is a minus 6. Let's remove that. Plus 6, plus 6. The 2x comes straight down. Negative 6 plus 6 makes 0. And then equals negative 15 add 6 is negative 9. So we have 2x is equal to negative 9. Let's remove this coefficient of 2. Coefficients can always be removed using division. Divide by 2, divide by 2. 2 divided by 2 is 1x equals, and this is negative 9 divided by 2, which does not work out to a whole number. And so the fastest way to write the result is to write it as negative 9 over 2, a fraction. This could be written as a mixed number, negative 4 and a half. It could be written as a decimal, negative 4.5. But unless there's a real reason to do that, you know, in the context of the problem, maybe there's an actual purpose to write it as a decimal. You know, without any context to this, it's certainly fine to leave this as a fraction. The fraction is the quickest form possible to write. And so x equals negative 9 halves. This is the answer we think is correct for x. And in part B, we can check to see if we're right. So part B, 2 parentheses, and then negative 9 halves gets filled in for x, and then subtract 3, close the parentheses, and does that equal to negative 15, we wonder? Well, let's work this out right here and see if it does make negative 15. Okay. So following the order of operations, we need to work in the parentheses first. We have negative 9 halves, and we want to subtract 3. Okay. So negative 9 halves, subtract. How about changing the whole number 3 into a fractional version that's still equal to 3, but it's a fraction that has a denominator of 2? then we'll have common denominators and can do the subtraction. So the whole number 3 is equivalent to 6 over 2, 6 halves. Does that equal to negative 15, we're wondering? Now still inside the parentheses, negative 9 halves, subtract 6 halves. Negative 9 subtract 6, that's negative 15 halves. Now what is 2 times negative 15 halves? If we think of the whole number 2 as 2 over 1, and then multiply by this fraction, you might notice the cross-canceling that happens with the 2's. This 2 in the numerator, this 2 in the denominator, cross-cancel, and leaves negative 15. So negative 15 equals negative 15. That checks, and that means that this is the correct answer for x.